Hello, this is Dr. Hanaa Assil, and this is Combined Science, and we're talking about physics. This is chapter 2, so we're going to be talking about speed and acceleration. You know that speed is basically how fast an object is moving, and the speed is measured by distance over time. Units of speed is in meter per second, and we know that from this equation, if I want to get distance, then distance is speed times time. So this is the basic equation that you need to know. Speed is distance over time, or distance is speed times time. Okay, what we will have is distance time graphs. He will give you a graph of the distance versus the time and asks you questions about it or asks you to analyze it. You should know that if I have a graph like this, distance versus time, and all it has is a horizontal line, you should realize that the horizontal line means the distance is not changing, and that means that the object is standing in its place. It's not moving. So this is for a stationary object or an object that's not moving, and that means the line will be straight. The distance is not changing. Now, if I have a graph in which an object is moving, now the object will be moving. That means it's moving away from a certain point, and that means the distance is increasing. So I have here three objects, A, B, and C, moving away from a certain position. Now, looking at the graphs, you should realize that the slope of this graph is the speed, distance over time. That's the speed. So the bigger the slope, the higher the speed. So which of these is fastest? You should realize that A is faster than B, B is faster than C, and they are all moving at a constant speed. So when you have the distance time graph and it is a straight line, it's a constant speed. Okay, so distance versus time. The line is going up from A, that means the distance is increasing, that means the object is moving away from A at a constant speed. Now, once it reaches a point and it stops, it's at rest, the horizontal line indicates that my object is no longer moving or it has become stationary. Now, line going down, that means that the speed is decreasing, and this is the object returning to its original point. Acceleration means increase in speed. So if the distance time graph is not a straight line, that means it is not constant speed. Now, if the line is going up, that means the speed is increasing and the object is accelerating. If the line is going down, that means the speed is decreasing and the object is decelerating, or the speed is becoming less and less. Okay, so you should realize that in a distance time curve, the slope is the speed. The slope, the gradient, you should know that to obtain the gradient or the slope of any graph, it is the increase in y over the increase in x. So the difference in y, so in this graph, for example, it's 40 minus 20, so that's 20 meters, divided by the difference in the time, so that's 4 minus what? 4 minus 1.5, so or 2, so that's about 4 minus 2, so it's about 2 seconds, and the speed is 10 meters per second. So you can get the speed directly from a distance time graph. Now, if we're talking about a speed time graph, now this graph looks very similar to the previous one, but this is now a speed time graph. So in this case, if the line is going up, that means the speed is increasing. That means the object is accelerating. Now, if I reach a horizontal line in the speed time graph, the object is still moving, but it is moving at constant speed. You understand the difference? The other one was a distance time graph, and we said the horizontal line means the object is not moving. But here, this is a speed time graph, so a horizontal line means that the speed is the same. That means it is moving at constant speed. Now, if the line is going down, that means the speed is decreasing, and that means that the object is decelerating. So, acceleration is a measure of how the speed changes. If we have increase in speed, that is called acceleration. Decrease in speed, that is called deceleration. If I have a speed time graph and it is a straight line, that means it is constant acceleration. The object is moving at increasing speed constantly. But if in the speed time graph the line is horizontal, that means there is no acceleration. The speed is constant, so there is no acceleration. If the line starts to go up, that means it is accelerating constantly. And if we're doing the distance time graph, we said if it's a distance time graph and the line goes up, that means it is accelerating. If it's a speed time graph, then the line should be a straight line, and that is also a constant acceleration. Please notice when you get the graph, is this a distance time graph or a speed time? And of course, if I have a speed time graph to calculate the acceleration, again, the acceleration is the change in speed over the time. So that will be the slope of that graph. So calculating the slope, or final speed minus initial speed over the time taken, that will give me the gradient, and that will be used to calculate the acceleration of the object. If I have a speed time graph and it is a straight line, we said this means constant speed. I can get from that the distance, because we said speed is distance over time. The distance is the speed times the time. So in this case, if I have a speed time graph, the area under the curve is the distance. Now, how do we get the area under the curve? That's basically the area of a triangle. That's half base times height. So half of A times B. Or you could just say the average speed. Average speed in this case means the initial speed minus the final speed divided by 2. That is average speed. And that means you can either get it from average speed times time, or you can get it from the area under the curve, which is half A times B. In both cases, you should get the same. Okay, thank you for listening to this video, and I hope you'll follow with the coming videos. Thank you.